In this video, we're going to see how to perform simple linear regression, an analysis when we want to model the relationship between two continuous variables. I'm using the big class dataset available in the sample data directory. To perform the simple linear regression in JUMP, we can use one of two platforms, either Analyze Fit Y by X or Analyze Fit Model. For this example, I'm going to use Fit Y by X. Fit Y by X is a contextual platform, like all platforms in JUMP, and so it'll produce different output depending on the modeling types of the variables you provide. In this case, I want to predict the weight of students on the basis of the height of those students. I'll cast these variables into their associated roles, and you'll notice JUMP will designate this analysis as a bivariate. When I click OK, JUMP will produce the scatter plot of height on the x and weight on the y. To run the linear regression, we'll go to the red triangle and select Fit Line, which will produce the linear fit information, summary of fit data, analysis of variance table, and parameter estimates for regressing weight onto height. In this case, we can see that we have a statistically significant effect of height on the weight of each student. Under the parameter estimates section, we can also see the actual beta estimate, standard error, t-ratio, and p-value for this relation. Under the red triangle next to linear fit, we have several other options that might be of interest, including saving the predicteds or saving the residuals to the data table, plotting the residuals, adding confidence intervals, including shading and confidence intervals for the individual fits. I'm going to run Save Residuals, and you'll see that the residuals for this analysis are saved to the data table. In diagnosing linear regression, it's often important to look at these residuals, and JUMP makes this very easy by plotting the residuals directly in the analysis. Selecting Plot Residuals produces several diagnostic plots, including residuals by predicted, the actual scores by predicted, residuals by row for diagnosing non-independence, and residuals plotted against x. If we're diagnosing the normality of our residuals, we also get the residual normal quantile plot, showing the expected eccentricity of the residuals, assuming that they form a normal distribution in the population. Residuals falling along the diagonal then indicate that those residuals are where they're expected to be if they were a part of a normal distribution.